Okay. Yeah, so we got some pretty strong gusty winds today. Some sustained winds of probably, I'd say, high 20s. But just to kind of show you what's going on here with my new setup. The way it works is if you watch any of my other videos, you'll kind of get an understanding of what is going on. Let's see, let's get this weather station connected here. The winds that we're getting right now are actually they're actually activating the voltage reducer that I have in here, which in turn turns on the relay, disconnecting the 500 watt inverter and only leaving the 1000 watt inverter connected. Okay, so let's see, you can see there's the winds. I'm just trying to reach up here and plug this in. We had a high wind gust of 28 miles per hour a few minutes ago. Okay, apologize, I'm shaking around here. Okay, so there's our current reading. You can see here we got 177 watts. It's pretty consistent today. I mean, here we go. So you can see this one here is working. These two actually work when they hit around 22 volts. They work together. 24, 26 volts. So you can see, here's our wind. Yeah, see how our winds are gusty today. There's our latest. This is the latest information. This is real time from the weather station. It's a Davis Vantage view. There's our high wind and our high gust today. So it is fluctuating between that and obviously 13, 14, 15 miles per hour. We'll wait for another strong breeze to come in. And we actually have some snow out there today. I don't know if you can see the snow. Flurries all over the place. See if we can get a peek on here. Yeah. Okay. Anyway. Oops. So yeah, there's our voltmeter, our amp meter. It's just showing. See, now that I come out here, I just got home from work. I figured I'd come out here because the wind was really whipping out there. And now that I've come out here, we don't have any wind. Okay, there you go. This is AC watts. I'm going to read let's see, we're at 10 mile an hour. Oops. 15. 7. I'm sorry, 8, 9, 8. So that's been pretty consistent. I gotta hook this back up here. And I haven't really been home much to work on this setup, so it's kind of just thrown together quick here. I got a heatsink zip tied to this rectifier for the moment. I have a heatsink for this rectifier on order. Let's see, just to see what our accumulated power is here. Kind of share this with you, because this is the first time I'm looking at it too. Oh, these screens. I hate these screens on these things. Okay, so 4.29 kilowatt hours and 389 hours. Okay, so you could do the math, figure out on average the kilowatt hours produced per day. Granted, some days we don't have wind. Some days we have winds like we're getting today. You know, but it'll be pretty consistent around there, around 10 amps all day. I'll take 10 amps all day into the grid tie inverter. Okay. Well, like I said, I haven't been around much. I've got some other things going on that I got to take care of. And it is freaking cold out here. But I'm waiting for one of these really big gusts to come in. Here we go. Nope, that's a car. But okay, so you can see the light is blinking. that means that the voltage reducer is sensing voltage, but it's not enough to trigger it. It's not enough to actually turn on the reducing circuit to allow it to activate the relay, which disconnects the 500 watt inverter and leaves the 1000 watt inverter all by itself. See, right now, the way it's set up right now, when the voltages are under 24 volts, both inverters are working together. They're connected in parallel. Here we go. See if we get a strong gust here. See, look at this. See, I get pretty, I missed it. Missed it. It was over 200 watts. I get some pretty consistent power. Now, before the 500 watt inverter disconnects, they work together at a certain voltage. I guess as together as they can. I mean, I really don't know. There we go. What do we got now? Okay, now we're up over 15. Here we go. I'm going to try to do this as quickly as I can here. Oh, you know what? Let me put the laptop right here so I don't have to keep. Ow. Well, there goes that idea, I guess. Put it right here. Just rip that right out of that camera. Oh well. I'll unplug it. Okay. So, the gauge is pretty cool. The actual number is right underneath it. Okay. So here comes the wind. And it died out again. There's AC watts. Okay, and we're still working off the 500 watt inverter. The 500 watt inverter really, it works well. I mean, I know they're not the greatest devices in the world. There's much better out there, but yeah, the box is cold, nothing in there gets hot. Here we go. I could hear that roaring out there now. Here we go, here it comes. There, now the 500 watt inverter is the only one on. So here we go, just to kind of give you an idea. Oh, there we go, 300, 395, 394. And we're still on. Okay, now it disconnected. Okay, that was a 22 mile an hour gust. But that's the kind of wind I get here. There we go again. Okay. Fully automated. No Zener circuits. I know there's a couple guys out there that are doing the Zener circuits. And hey, they work great. But the only problem is, I don't know, just a lot. I had one of these voltage reducers, so I figured I'm going to use it instead. And it seems it's working better for me. Okay? It's working better for what I'm doing. I like it. I don't have my drill with me, so I can't even pop the cover off to show. Well, watch my other video, electrical update or whatever I called it, and you can see what it's doing. See, this one here gets disconnected when now it's disconnected. So I got high voltages there. It'll drop down and disconnect. So it basically, it's acting like a brake, but it's automated. It's 23 mile an hour gust, 15 mile an hour winds, 14. So I'm giving you real-time wind with real-time power. There's a 248, 186, 231. There we go. Here comes that big mamma jamma. There's a little bit of a delay. Oh. See, and it'll over rev until it kicks in. And then now, see, I see these kind of. I'm not catching it. I got to get all this stuff closer together. Here we go. That's 26 volts at 16 amps. You know, so I'm seeing some pretty decent power out of this. I like this turbine. But I can't wait until the micro wind turbine industry is revolutionized and standardized. That's pretty damn good. Now that's only this inverter. You can see this one's not doing squat, it's just kind of hanging out. But it gives me a higher wind power. Higher voltage, higher amps, or higher voltage, lower amps gives me about the same amount of watts as low volts, high amps. I prefer higher voltage, lower amps just because of the efficiency. And I haven't done anything different to this. I haven't done anything to this setup since my last video. I haven't been out here. And it's been too cold. I was actually in the Midwest for Christmas. And I was able to monitor all this from there. I'm working on a little setup that'll allow me to basically remote control this setup here. 23 mile an hour gust again. So you can see the winds are varying. Yeah, I'm trying to figure out what I want to do. I'm going to keep the Windy Nation turbine up, and I think I'm just going to go solar. There is too much bullshit with wind right now. Too much bullshit. I don't even think I'm going to, this is it for wind for me. I still haven't had a chance to test the high turbine. I'm hoping one of these days when I just get some time to come out here and couple it up to one of my electric motors, or maybe even my small diesel. I'll hook it up to that, and just see. I gotta get the RPMs up on it and load test it and voltage test it and see what I'm getting out of it. But as far as I'm concerned, it's still sitting there. Still sitting there. Hasn't moved. Haven't touched it. But see, here's the thing. If I decide to keep it, as I haven't gotten a reasonable price an offer on it yet. I got about 4 or 5 emails, but they're not numbers that I'm willing to part with it for. Because sure, maybe the turbine is fine. Maybe the stator is fine. Maybe the slip ring is fine. I don't know. But I was told by High Energy that the 48 volt turbine will not charge a 48 volt battery bank, which is strange to me. I don't understand that. I see 12 and 24 volt turbines charge 12 and 24 volt batteries. But I have a couple of these. Oh, here we go. Let's see if we get some. Yeah, let's see the amps on that. That's wind. That is wind. That's not gust. That's wind. I'll take that all day long. Sure. Look at that. Wow. Holy shit. There we go. What do we got here? Oh, now holy fudge. Come on. There we go. I could hear the wind howling. Look at that. That is cool. That It is freaking awesome. I hate that blue light, but you know what? I don't have any red ones. So I apologize. I know it's glary on the camera. That's why I hate those blue digital LED meters, the volt and amp meters. I hate those things. The red ones are better. They're easier to read. But I have a couple things cooking here. I got this. This is an old one. I have a bunch more of these. Anybody that's... Let's just plop that there carefully. The metal frame is a little bit rusted out. But it's nowhere... It works. There's no shorts in this transformer. This is a 36 volt. There's DC out, DC out, DC out. 36 volt transformer. Here we go. Sorry, the wind keeps distracting me. Shoot that fucker up. Isn't that awesome? It's bloody awesome. Freaking awesome. Anyway, this is a 36 volt transformer. 110 volt goes in here. This hooks up to a run capacitor. There's another one. Here it is. These two wires hook up to a run capacitor. This one's just missing a sheathing, and these will be AC out. 30, I think they're 45 volt output. This one and this one. They go through diodes. It's 36 volt battery charger transformer. So I have 48 volt battery charger transformers. I got about 4 of them. So I have an idea, since I'm pretty much stuck with the high turbine, I'm gonna try something that I wanted to try a while ago, but I wanted to try to get my money back for it, but that doesn't seem like it's gonna happen. There's a 22, you know, and nothing out here is warm. Even the rectifier heatsink, that's not even warm. The heatsink's doing a really good job of keeping that cool. I mean, it's 22 degrees out here. Alright, let's watch this for a second. Look at that. So, but my idea, I think, you know, they have standard ratings for solar panels. A 100 watt solar panel in optimum conditions will deliver optimum output. Okay, a 100 watt solar panel should deliver 100 watts at a specified voltage under optimum conditions. Yeah, see, look at that. That's pretty cool. And I think the micro wind turbine industry, you know, most people will see this kind of wind. Like, this is normal wind. The high turbine, based on the spec sheet on their website, not rounding numbers up, because rounding up is cheating. The high turbine, the HY 1000L, is rated 1000 watt output at rated wind speed of 26.8 miles per hour. Not 27, not 30, 26.8. Okay. See, now you can see there's 29 mile an hour winds. I had these when I was doing some testing. Now, I didn't do video on it because I just didn't do video on it. And I wasn't getting these kind of numbers out of that inverter on the DC side, rectified. Am I supposed to? I don't know. I'm not saying I should, but it should be putting out some type of power. It was barely able to break 6 to 8 amps. Okay? It wasn't coming anywhere near. Now, if it was giving me 500-600 watts, then, you know, I'd be happy with it. I'd leave it up on the pole. But I wasn't getting that. Did I get a bad turbine? Possibly. You know, it's a 48 volt turbine, and it's not something I've ever played with before. I mean, I've played with 12 and 24 volt setups, but not higher voltages. But I don't know. I think wind turbines should be rated at 25 miles per hour. It's a nice, easy number. It's easy to get wind speeds at 25 miles an hour. During some people get them during the winter, some people get them during the summer, some people have them all the time. You know, 25 miles per hour rated power output should be achieved. You know, if you sell a turbine at 2,000 watts, you know, it should be able to generate 2,000 watts at 25 miles per hour. You sell a turbine at 500 watts, it should be able to generate 500 watts at 25 miles per hour. It really needs to be standardized. It really does, because it'll shut down a lot of these fly-by-night thieving wind turbine companies. It'll eliminate all the wars, and if it can't do what it's advertised to do, the FTC should get involved and say, okay, get it off the market and buy back all the turbines that you put out there that are not performing. They're not doing what you're claiming that they'll do. You know, that high turbine weighs close to 80 pounds. That generator head is heavy. That generator weighs almost 60 pounds. The rest of it's tail fin and body, slip ring and screws and nuts and bolts and all that shit. That generator weighs almost 60 pounds. 60 pounds and, you know, extruded aluminum bodies and faceplate covers and rotor, you know, there's not a lot of mass there. I mean, yeah, the magnets are heavy, but okay, let's be conservative and call it 40 pounds of copper. All right, I highly doubt it's 40 pounds of copper, but it's probably close to 20 pounds of copper in that thing. You know, you take an induction motor, a 3-phase induction motor. Here we go. Take this motor. This motor weighs 30 pounds, and it's a 1 horsepower, 120 volt. I'm sorry, 1.8 horsepower, 120 volt compressor motor with 2 start run capacitors mounted to the top of it. God, I hope this thing doesn't kick on while I'm standing here. But anyway, that's what I feel. Solar panel industry is standardized. They're all in. Most of them now are MC4 connectors until somebody comes out with a better idea. Most of them are UL listed. These things are not, but they're plugged in. You know, I can unplug it. You know, boink, unplug it from the wall. It's not hardwired. Most UL inverters are hardwired. Most UL anything in this industry is hardwired. N-phase inverters for solar, for example, they're hardwired. I mean, you could jerry-rig them and splice them and put a 30 amp 220 plug on it, but then it's not UL listed anymore. And the warranty is void. But yeah, it's got to get standardized. It needs to be standardized. It really does. Because there's going to be people out there taking motors like this, taking them apart, putting rotors and magnets in there, and calling it a 3-phase double axle 5,000 watt wind turbine. Okay? No. No. Standardize. Standardization. Standardization. And, you know, I also got wind that people think that I bought that high turbine in order to bash it. No, not true. Not the case by any stretch of the friggin' imagination. I bought that turbine because I wanted to see what everybody was all excited about, seeing power output. I didn't get that, and I was pissed. Wouldn't you be pissed too? Yeah, I think you would. And, you know, and it's not the first time that I got the runaround from a company. No matter what the product is, I got the runaround from several different companies for several different products because they said it was my fault, and then, when in fact I know it wasn't. Because I bought a similar product from a competing company, and it worked with the same exact setup. I'm talking about a water heater that I bought. The first one I bought, oh, well, it's your setup, it's your water pressure, it's this, it's that, it's your gas pressure. No, the hell it isn't. No, the hell it isn't, because I have a water heater now in place that is 4 times the size of it, and it works better. Way better. Like, told me it was my fault, when it wasn't. And there's nothing different. It's the same gas pipe. What the hell is that? Same water line. So no. But alright, that's my rant. Like, share, subscribe, or not. I don't care. I don't know what that's all about anyway. But hey, you like these videos and there's something else that you want to see, or you want me to go in more detail about the setup, let me know. Leave it in, you know, a comment, or send me a message, or whatever. Or if you want to know all about this stuff here and all that stuff, that's pretty straightforward. But those voltage reducers, I do sell them. I do sell them. I have better ones now. I have several different models, different voltage ranges, so let me know if you're interested in something like that. I can get them for you too. Pretty good price. Okay. Alright, YouTube, I'm out.